Hello and welcome to this video tutorial for the Eclipse SDV Hackathon Chapter 2.
Today, we are going to give you a brief introduction to our challenge Forget the Conventional, Shift to SDV, and Focus on the Used Projects.
In our challenge, we are targeting to reach the highest SDV level, Level 5, the Innovation Platform. At this level, even third-party applications can be dynamically deployed to enhance the vehicle functionality.
You can find more information on the SDV levels in the blog post from Moritz Neukirchner by following the provided link.
In the challenge, we're using the following Eclipse SDV projects.
Eclipse Ankaios, an embedded container orchestrator targeted at automotive HPCs.
Eclipse Symphony, a meta orchestrator helping you manage your fleet from the cloud.
Eclipse eCal, a fast communication middleware following the publish-subscribe principle.
The Ankaios dashboard, a graphical user interface for the Ankaios orchestrator. Let's start with a short introduction of Eclipse Ankaios. Oliver, how exactly does Ankaios help us reaching the highest goals that we set for this challenge?
Ankaios is a software orchestrator targeted at the automotive use case. It is a powerful solution to manage applications in the vehicle. A developer can easily develop and test the application outside of the vehicle and put the applications with all dependencies into an OCI container image. Subsequently, all the applications are deployed to the vehicle and managed by Ankaios. Ankaios follows the Unix philosophy to have one tool for one job and doing that well, meaning managing a huge number of applications in a modern software-defined vehicle with all their interdependencies. Kalayan, how does Ankaios manage applications in the vehicle?
An in-vehicle Ankaios cluster is composed of one server and multiple agents. Ankaios can run applications as workloads that are executed on a certain compute node where an Ankaios agent is running. To give more flexibility to the system, Ankaios supports the operator pattern, where privileged applications running in the cluster can modify the state of the cluster itself. This allows us, for example, the possibility to create a fleet connector that manages the vehicle from the cloud. Ankaios also enables fast and easy development by providing a CLI that can be used from the outside as well as the inside of the vehicle.
You can get more information on Ankaios in our comprehensive documentation. There we will show you how to install an Ankaios cluster and do an easy quick start, tackle example use cases in detailed tutorials introducing important concepts of Ankaios, and configuring your cluster depending on your demands. Check that out.
Great. So let's just have a quick overview of how Eclipse Symphony enables such scenarios. So basically, Eclipse Symphony aims to provide an end-to-end consistent experience across different technologies, right? Regardless if it's a different operation systems, different payload types, different devices, different protocols. So Symphony provides this extensible architecture so that you can easily connect different systems into Symphony through various agents and providers. And if you go to the next slide, we can show you how Symphony enables such scenarios. Basically, Symphony creates these 4 high-level abstractions. These abstractions allow us to provide the Symphony solution in a very technology neutral way. The first part is the orchestration model. So basically, we provide this orchestration model for you to model your problem. So this is a key difference, right? Instead of jumping into modeling a solution, we want you to be able to model your problem so that the problem is clearly articulated across the life cycle. Then you can use this problem modeling then to find correct technical solutions to a problem. And as in the operation phase, we mostly use state seeking as the foundation of operation. So basically, your system declare reports of current state, and the user defines a desired state, and Symfony runs this reconciliation loop to bring your current state to the desired state. So with this abstraction, we can cover a lot of scenarios, such as software deployment, device update, configuration rollout, policy reinforcement, sidecar injection, etc. So this is what I mean, right? By using these high-level abstractions, we can actually provide those kind of consistency across different technologies. And the other aspect we bring in is the information graph, where a lot of not only SDV systems, right? In many systems, they need to manage an information graph, given if it's a asset topology or configuration hierarchy or application template, etc. And we treat everything as abstract information graph so that you have the greatest flexibility to model the ontology of your information and to map that into the corresponding actions that Symfony can take. And last but not least, we have a workflow engine because state seeking is the final goal, right? But in a lot of cases, how you reach that state matters as well. For instance, you may want to do approvals before a deployment is rolled out. You may have a maintenance window that you have to schedule deployment at a certain window. And you may want to have like a CI/CD integration. And also, if you have like a multi-site coordination, we allow you to run those kind of a distributed workflow as well. And here is a high-level architecture of Symfony. And you can see it's designed in a very horizontally scalable architecture. The boxes in the middle, you see those list of nano services were included in the Symfony. So basically, additional functionalities can be added to the system without impacting the other part of the system. And we also build up the protocol neutral layer so that the Symfony APIs, once you get into it, you can see you can consume Symfony API through HTTP, MQTT, or you can have your own protocols to consume that.
Let's move on to the next Eclipse project that is part of this challenge, Eclipse eCal. My name is Rex Schilasky, I'm one of the project leads, and I would like to give you a short introduction. eCal stands for Enhanced Communication Abstraction Layer. It's an open source, high performance in the process communication. Think of it as a powerful tool that allows software components to exchange data with each other quickly and efficiently. eCal supports two types of communication patterns, publish-subscribe and client-server. It doesn't matter if your data producers and consumers are running on the same physical device or if they run distributed across a network. eCal will automatically establish the needed connections with almost zero configuration effort. To distribute your data, eCal is using different kinds of so-called transport layers, as there are shared memory, TCP, or UDP. Even eCal itself is written in C++, you can also use other supported languages like Python or C# to implement your eCal application. eCal supports the Windows operating system as well as POSIX systems. Lastly, eCal comes with powerful tools to record data flows, to replay them, and to monitor all running nodes in a live view monitoring tool. Here's the classic Hello World example. You can see how simple it is to create an eCal publisher in C++ and to subscribe it in a Python script. As mentioned, it doesn't matter if these two applications are running on the same machine or on different devices. eCal will handle this seamlessly for you. eCal's API allows you to focus on implementing your algorithm without worrying about how to communicate your data. You can concentrate on your hack. eCal will do the transport job for you. Finally, here you can find all information you need to get started with eCal. Just scan this QR code to access the documentation page, which has everything you need to dive deeper into using this powerful framework. Good luck and happy hacking!
Hello everyone and welcome to the Ankaios dashboard. My name is Felix Mölders and I will give you a quick deep dive into what to expect from the dashboard. The workload orchestrator Eclipse Ankaios is, as most of orchestrators, controlled and interacted with via an CLI, so control line interface. You can see on the top right that, for example, if you want to see what workloads are currently in the system, you use the ankget workloads command and get a overview of a table of workloads. This is not that intuitive if you're using the system for the first time, and you don't see dependencies and other information that are hidden behind the table. Therefore, we provide the Ankaios dashboard, as you can see below. It gives you a quick overview of what workloads and how many are running in the system, on what agents, and some other information that might be relevant for debugging. Furthermore, we provide two other views. The first one you can see here is the workloads view. There you have the chance or the feature to delete workloads that are currently running. You can see whether and what dependencies they have. You can go to the config section and configure them on the fly, but also you are able to start new workloads in a running cluster in a very intuitive and easy way. Furthermore, as Ankaios offers the feature to have dependencies within workloads, you have a dependency graph that visualizes those dependencies in an easy way, especially for debugging. So, for example, the smartphone music streaming is depending on a running smartphone Bluetooth connection, or the EV charging error is dependent on a failed EV charging start. Those are the two main views that will help you when developing with Ankaios. Furthermore, the last thing you should know is that the Ankaios dashboard is started as a workload within the cluster. A cluster in general consists of a server with 1 to n, so multiple agents that manage the workloads. You can start it with a YAML config file that is either added to the startup state YAML that you start in the beginning together with a cluster, or you can use this excerpt of config and apply it via the ank-apply command. Use this QR code to get to the GitHub repository. There's some more documentation on how to start and run the system. And that's it from my side to the Ankaios dashboard.
We are looking forward to see you at the Eclipse SDV Hackathon Chapter 2 in Karlsruhe.
Forget the conventional shift to SDV.